Good morning, everyone. Today, we are going to start our next unit, that is the P block elements, in which we will discuss about different topics, different subtopics related to the P block, is the introduction about the P block elements, their electronic configuration, the different type of shells or the subshell, different type of valence shells, screening effect, and the penetration power. These are the different terms which are generally being discussed before the discussion of the main questions of the P block elements. So let's start P block elements. So what are the P block elements? P block elements are those elements in which the last electron enters into the P subshell. You can see in that particular diagram. That is the configuration of element. You can see 1s2. In the first shell, there are 2 electrons. In the second shell, there are 2 electrons, 2s. In the 2p, there is 1 electron. So what is the total number of electrons? The total number of the electrons are 2 plus 2, 4 plus 1. That is a 5 electron. 5 electrons means atomic number is 5. So that diagram is for boron, whose atomic number is 5. In case of boron, you can see the last electron enters into the p subshell. So all the elements in which the last electron enters into the p subshell are called as the p block elements. So that is the definition of p block elements. Whenever that particular statement comes in your examination, you must have to draw that particular diagram along with the definition. The p block contains 6 groups. There are total 18 groups in the periodic table. Out of these 18 groups, the 6 groups which ranges from group number 13 to group number 18, they come in the P block. Why only 6 group? You can see in the P subshell, here you can see in the P subshell, there are the 3 orbitals and maximum 6 electron can be placed in them. 2 plus 2 plus 2, 4, 6 electron. So as there can be a maximum of 6 electron can be placed in the P subshell, so the P block has 6 group. The group ranges from group number 13 to group number 18. Now we can see about the elements of group number 13, 14 and so on. So group number 13 elements are boron, atomic number 5, aluminium, atomic number 13, gallium, atomic number 31, indium, atomic number 49, and the thallium, atomic number 81. Similarly, the elements in group number 14 are carbon, silicon, germanium, tin, and lead. You can see the atomic number of these elements. Now, what is the configuration of boron? 1s2. 1s2 is the configuration of helium. So we just write here helium in the square bracket because it has the fulfilled configuration. Helium has the fulfilled configuration. It is a group 18 element. So we'll just write here helium followed by the remaining configuration, that is the 2s2, 2p1. So what is the configuration of boron? 1s2, 2s2, 2p1. And we write here one helium in place of 1s2. Now, what's about the remaining elements? Aluminum, gallium, indium, and the thallium. As we move down the group, in any of the group, as we move down the group, the number of the shell increases. Here, the valence shell is second, 2s2, 2p1. That's the valence shell configuration of group number 13. Now, what is the valence shell configuration of aluminum? The valence shell configuration of the aluminum just below the boron, aluminum is present. So the configuration will be 3s2, 3p1. 3s2, 3p1. And the remaining configuration is of neon. Just write here the neon. What about the valence configuration of the gallium? Just increase one number, one shell, 3s2, 3p1. In place of 3s2, 3p1, we will write here 4s2, 4p1, 4s2, 4p1, and 3d10 here. Why 3d10 here? In case of aluminum, you can see there is the third shell, 3s2, 3p. Means what is the next? In the third shell, there are 3 subshell. S, P, and D. It means 3D is vacant here. In case of aluminum, vacant D orbital is present. And that vacant orbital is first of all filled up completely before filling the electrons in the 4s2 and 4p1. So the conjugation of gallium is 3d10. Remaining conjugation you can write here 1s2, 2s2, 2p6 like that. But you just have to learn that there is a full-filled d subshell in case of gallium, and there is vacant d orbital in aluminium. Because in aluminium is a third period element, because the last electron enters into the third shell, that is a 3s2 3p1. 3p1 last electron enters into the 3p, means third shell. Means in the third shell there are three subshell, sp and d. So 3d is vacant here. So whenever that particular question is asked in your exam, name the element which has vacant d orbital. Whether boron has vacant d orbital? No, because their configuration is 1s2, 2s2, 2p1. In second shell, there is only s and p. There is no 2d. So there is no vacant d orbital in boron. While in case of aluminum, there is vacant d orbital. 3d is vacant here. And that 3d vacant is filled here in case of gallium. Okay, so next element is after gallium, that is the indium. What is the valence conjugation of indium? Just increase one number, 4s2 4p. In place of 4s2 4p1, what's there in indium? 5s2 5p1. 5s2 5p1. Why we write here 4d? Because in case of gallium, you can see the valence shell is fourth shell. 4s2 4p, fourth shell. In fourth shell, there are four subshell, 4s, 4p. Now there are 4d vacant, 4f vacant. 4d is filled here in case of the indium. And what about the 4f? That 4f is filled in the next element, that is the thallium. So what about the valence conjugation of thallium after 5s2 5p1 in indium? The valence conjugation for the thallium is 6s2 6p1. And you just fill here. What do you fill here? 5s2 5p 5d. You have just fill the 5d10 and 4f 15 for 4f 14 here. So that's all about the electronic conjugation of the group number 13 elements. So what you learn here? You learn here up to that what is the definition of p block elements. So the element in which the last electrons enters into the, where it enters? It enters into the valence p subshell. So these are the p block elements. P block element contains 6 group. Why 6 group? Because the p subshell has 3 orbital and maximum 6 electron can be placed in it. So the p block has 6 group. And what is the range? Group number 13 to group number 18. Now, what about the elements present in the group number 13 and 14? In group number 13, the elements present are boron, aluminium, gallium, indium, and the thallium. What about the element present in the group number 14? Carbon, silicon, germanium, tin, and the lead. What about the configuration? We just write the configuration here. Now, what are the important question here? Name the element which has no vacant d orbital. That is the boron. Boron has no vacant d orbital. Which is the first element in group number 13 which has vacant d orbital? After boron, the next element, that is the boron, that is the first element in group number 13 which has the vacant d orbital, that is the 3d vacant orbital. In case of gallium, there are vacant 4d and 4f. In case of indium, there are the vacant 5p, after 5p, 5d, 5f, 5g. Name the element which has fulfilled F subshell, that is the thallium. Thallium has 4F subshell, that is completely filled, 4F14 here. Similarly, you can write the electronic conjugation about the group number 14. Just increase one number of group number 13, that you can see here. The valence conjugation of 13 here is 2p1 in case of boron, 3p1, 4p1 of gallium, 5p1, and so on. Just increase 2p1 means 2p2 in case of group number 14, because on moving from group number 13 to 14, one electron will increase, means atomic number boron is 5, atomic number carbon is 6, means one more electron in carbon. So what about the configuration of carbon? 2s2 2p1, valence conjugation. Similarly, about the silicon, 3s2 3p1, about germanium, 4s2 4p2, tin, 5s2 5p2, lead, 6s2 6p2, and remaining things remain same. Okay. Now, what about the remaining group elements? Group number 15, 16, 17, and the 18. The element in group number 15 are nitrogen, phosphorus, arsenic, antimony, and the bismuth. In group number 16, oxygen, sulfur, selenium, tellurium, and the polonium. What about group 17? Fluorine, chlorine, bromine, iodine, and the astatine. In group number 18, helium, neon, argon, krypton, xenon, and the radon. Now, similarly, you can write the electronic configuration of group number 15. 1s2 2s2 2p3 लास्ट में 2p3 आपको यहाँ पे दिख रहा है तो फॉर द फास्फोरस 3s2 3p3 आर्सेनिक 4s2 4p3 वैलेंस कॉन्जुगेशन आई एम टॉकिंग अबाउट Sb antimony 5s2 5p3 bismuth 6s2 6p3. Similarly, you can write the conjugation of the group number 16 element. Oxygen 1s2 2s2 2p4. Sulfur 3s2 3p4. Valence conjugation of sulfur is 3s2 3p4. Selenium 4s2 4p4. Tellurium 5s2 5p4. Polonium 6s2 6p4. Similarly, for the group number 17, fluorine conjugation is 1s2 2s2 2p5. Next, chlorine valence configuration is 3s2 3p5. Bromine 4s2 4p5. Iodine 5s2 5p5. Astatine 6s2 6p5. Now the group number 18, 1s2. That's the only element in which the last electron not enter into the p subshell, although it is placed in the group number 18 to maintain the uniformity of the periodic table. Next element, that is the neon 2s2 2p6. Argon 3s2 3p6. Krypton 4s2 4p6. Xenon 5s2 5p6. Radon 6s2 6p6. So that is about the electronic configuration of these different group elements. Now, what is the general electronic configuration? The general electronic configuration of p block element is ns2, means S is always fulfilled, that is ns2. In case of valence p subshell, the electrons ranging from 1 to 6, because in group number 13 there is only one electron in the valence p subshell. Group number 14 there are 2 electrons. Group number 15 there are 3 electrons in valence p subshell. In 16 there are 4 electrons in valence p subshell. Group number 17 there are 5 electrons in the valence p subshell, and group number 18 there are 6 electrons. So the general configuration is ns2 np 1 to 6. So that is about the general electronic configuration. Now, what is the other name of group number 15 elements? The group number 15 elements are also called as nicogen, means due to their suffocating nature. Group number 16 elements are called as chalcogens due to their ore forming nature. They are present in the earth crust to form the ore. Group number 17 elements are called halogens due to their salt forming nature, like we already know about the NaCl salt we generally used in our homes. Group number 18 elements are also called as noble gases due to their low reactivity. The second period element you can see here, that is the nitrogen, oxygen, fluorine, neon. They show the unusual property due to the absence of vacant d orbital. इनके पास वैकेंट डी ऑर्बिटल नहीं होती. सेकंड पीरियड के जितने भी एलिमेंट हैं, दे डोंट हैव एनी vacant d orbital, so they will generally shows the some unusual properties. The last element in each of these group number 13 to group number 18 you can see. In group number 15, that is the bismuth here. Group number 16 polonium, 17 astatine, 18 radon. They show the unusual property due to the presence of F subshell. You can see there is the F subshell here. In group number 13, thallium, that is the F subshell, 4F is fulfilled. In group 14, lead, 4F is fulfilled. Due to that presence of that 4F14 in these last element of these groups, group number 13 to 18, they show something unusual property. What type of these properties we will discuss later on. The last element in the group number 16, 17, and 18, that is the group number 16 polonium, group number 17 astatine, and group number 18 radon. They are the radioactive elements. All element in group number 15 shows the allotropy except nitrogen. In the group number 15, nitrogen do not show the property of allotropy. We will discuss later on what is allotropy. Other element like phosphorus shows the property of allotropy, and so on. In group number 16, Oxygen and ozone, they are the allotropic form of the oxygen. All elements in group number 17 and 18 do not show the allotropy. So these are some basic things. Among group number 13 to 18, the gases are nitrogen is a gas, oxygen is a gas, fluorine is a gas, nitrogen in group number 15, that is a gas, oxygen in group number 16 is a gas, fluorine and chlorine in group number 17, these are the gases, and group number 18, these are the gases. The liquid non-metal is in group number 17, the bromine is a non-metal liquid. The solid are, other are solid, other remaining elements are solid. The radioactive element, as we already discussed, polonium in group number 16, S-theta in group number 17, and in group number 18, radon, that is a radioactive element. The metals are, aluminum is a metal in group number 13, gallium is a metal, indium is a metal, where indium is present, indium in group number 13, that is a metal. Bismuth is a metal, where bismuth is present. There is a group number 15, the last element, there is bismuth. Polonium, group number 16, last element. These are the metal. Non-metals are carbon, group number 14, silicon, group number 14, nitrogen, group number 15, phosphorus, group number 15, oxygen, group number 16, sulfur, group number 16, fluorine, chlorine, bromine, iodine, group number 17. Metallides, the boron, germanium, arsenic, antimony, selenium, tellurium, they come in the category of the metallides. Now, we will just see the valence configuration and we will see what is the number of bond pair electron and the lone pair electron in group number 15 to group number 18. In the group number 15, the valence configuration here is 2s to 2p3. Means in the valence 2s, there are 2 electrons. You can see here, these 2 electrons. And the 2p has 3 electrons, 1, 2, and 3. These are the 3 electrons. These are the 3 electrons. Means we are just talking about the first element of these group number 15, 16, 17, and 18. We are just at present, we are not talking about the remaining element of this group. In the first element of group number 15, 16, 17, and 18, so that configuration just you are seeing here with the red, blue color half arrows, these are the electrons. We are just showing the electron with the half arrow in blue color here. And these electrons are only of first element. What about the next element? Because in the next element, like in group number 15, the first element, that is the nitrogen, 1s2, 2s2, 2s2, 2p3, there are 3 unpaired electrons. There are 3 unpaired electrons. And there is one pair in 2p, there is one pair that called the lone pair. So what is the bond pair electrons in group number 15? There are 3 unpaired electrons, 3 unpaired electrons. Valency is 3, bond formation capacity is 3. Lone pair electrons, that is 1 lone pair. These 2 electrons are present in the form of the pair. Now, what about the remaining element like phosphorus, arsenic? Because in the other element like phosphorus, the valence configuration is 3s2, 3p3. Means in phosphorus, there is 3d, vacant d orbital. So if we have vacant d orbital, that 3s electron, these lone pair electron, one of the electron can jump into the 3d. So there will be the 5 unpaired electron, 5 bond pair electron. So means phosphorus can expand their valency. Means the valency of nitrogen here is 3 because it has 3 unpaired electron. It can form only 3 covalent bond. With the help of lone pair, it can form a maximum one more coordinate bond. Means the maximum valence is 4. 3 covalent bond and 1 coordinate bond in case of the nitrogen. While in case of the phosphorus, these s electron can jump into the vacant d orbital because in phosphorus there is vacant d orbital. Means in all these groups, means ranging from group number 15, 16, 17, 18, except first element, that is the nitrogen in case of group number 15, oxygen group number 16, fluorine group number 17, like that. The other element, phosphorus, arsenic, all other elements have vacant d orbital. While these first element, they don't have any vacant d orbital because they are the second period element because they have only second shell. And in second shell, there is only s and p. So there is no vacant d orbital, so they cannot expand their valency. So their lone pair electron cannot be unpaired. We can't unpair these paired electrons due to the absence of any vacant d orbital. So expansion of the valency can occur only in the remaining elements of these groups. Okay. So next we move towards the group number 16. Similarly, in group number 16, in case of the oxygen here, you can see there are only the two unpaired electrons. Means oxygen has two bond pair electrons, and these two lone pair. Means four electron present in the form of a pair, means two lone pair. So in case of oxygen, there are two bond pair, means oxygen can form two bonds while it has two lone pair electrons. You have to learn all these things always, because these things will be used during drawing of the structure, during determination of the structure related to these compounds. So these are the basic fact. These fact must remain in your mind. If you forgot, just write the configuration and see what is the number of the bond pair electron or the lone pair electron in their valence shell. Next, we move towards the group number 17. In group number 17, you can see there is only one unpaired electron in the 2p, one unpaired electrons, means one bond pair electron. These 6 electron in the form of pair, so means 3 lone pair. In group number 18, all electrons present in the form of pair, means there are 4 lone pair electron and 0 unpaired electron. You can make just a slight correction here. These are the, you just write 0 here. Just do the correction. 0 means bond pair electron 0 and lone pair electrons are 4 in number. Okay, just make it correct. So you can see the total sum is 4. 3 plus 1 4, 2 plus 2 4, 1 plus 3 4, 4 plus 4, on moving from group number 15 to 18. Okay, so what are the valence electrons? The electrons present in the outermost shell are called as the valence electrons. So you can see here the valence shell configuration. So what is the total number of electrons present in the valence shell? Called as the valence electrons. And these valence electrons are of two types. Some electrons are present in unpaired form, other present in paired form. The electrons which are present in unpaired form, which can take part in the formation of covalent bond, these called the bond pair electrons. So first type of valence electrons are bond pair electrons. Means the unpaired electrons which are present in the valence shell, which take part in the formation of covalent bond, these are called as the bond pair electron. You can see in these example. And the paired electron called lone pair electrons. The paired electron present in the valence shell which do not take part in the formation of covalent bond, however, they can take part in the formation of the coordinate bond or the dative bond. Or these can be unpaired. These lone pair can be unpaired in the remaining elements if any of the element has vacant d orbital. These can be unpaired. When you unpair these electrons, they will no longer be the lone pair electron. They become the, because they are unpaired, and unpaired electron called as the bond pair electrons. You just have to learn these basic facts. Okay. Means lone pair electron can be excited if the vacant d orbital is present. So these elements can expand their valency. In example, the examiner may ask the question, which of the following can increase their valency? Which of the following can increase the valency? So which can increase the valency? The elements which has vacant d orbital can increase their valency. Okay.